Hi guys, Erin here. In this video, we're going to be talking about non-experiments and quasi-experiments. In particular, we'll be talking more about the different ways that we can do them and how they differ, how these research designs differ in terms of internal validity. So let's get started. So this is a table from your textbook. It's really overwhelming. I totally agree. In these videos, we're going to be talking about these different designs. My hope is that by the end, you'll be able to determine for yourself which are non-experiments and which are quasi-experiments and why. They differ here in this table. They're grouped in terms of whether they can be considered between subjects designs over on the left, so designs that compare groups of people that already exist in the world, or whether they can be considered pre-post designs where we're comparing the same group over time. So in this video, we'll be talking about all these different kinds. In the next video, we'll be talking more about developmental research. Okay, so let's get started. Non-equivalent group designs. Here's the textbook definition. It's a research study that compares two groups of participants. The groups of participants are formed under circumstances that the researcher can't control. So we can't control who belongs to which groups. These groups just already exist in the real world. Because we can't use random assignment, we're not creating groups of participants. We're not measuring and controlling for possible third variables to make sure that they're not confounds. The groups of participants are therefore considered non-equivalent. So that's why we have non-equivalent group design. So you already learned about one example of this from the last video, differential research design. So in this design, we're comparing pre-existing groups that differ in some sort of characteristic that have to do with the participants themselves. So maybe we're comparing girls and boys, kids that come from more or less affluent homes, so looking at SES, or maybe comparing them based on their mental health status. So an example that we talked about from the last video is where we're comparing kids with or without ADHD on their quality of sleep. So the goal of this design is to establish whether or not there's a relationship between two variables and to describe the relationship. So this kind of design will always have this kind of structure. We'll have two groups, kids with ADHD, without ADHD, and we're measuring some other variable, in this case, their quality of their sleep. We're measuring in every participant in our two groups. We're getting an average of our ADHDers, our non-ADHDers, to see if there's a difference between groups. Now, we're not manipulating the groups. We're not saying you guys get ADHD, you don't. That's not possible. But importantly, we're also not controlling or measuring possible other third variables to ensure that they're not a confound in our design. And this is really important. So again, a confound is any variable that could impact our dependent variable that could systematically differ between groups. So in this example, it would be anything that could impact sleep that might differ between our ADHDers and our non-ADHDers. Well, maybe you can think of lots of examples that could fall into this category. For example, that are related to lifestyle factors such as nutrition. Maybe it might be, if we're not measuring quality of nutrition, how much caffeinated beverages they're drinking later in the evening. If it just happens to be that our ADHDers are drinking more caffeine than our non-ADHDers, well, this is a confound. This could provide an alternative explanation for any differences in sleep that we find. Similarly, if they differ in exercise, the extent to which that they can, provide an outlet for their energy, this could be a problem. If we're not measuring whether their parents are divorced or whether their parents have the, emotional capacity to really be in tune to what their child needs. If this differs between our groups, this could provide an alternative explanation for our difference in sleep. We have no way of knowing whether it is ADHD or these other factors that could explain this group difference. So differential research design, some of the key features of this is that we're comparing groups of kids. So this is unlike a correlation, like I talked about in the last video. So no, whenever you're comparing groups of people, you're not doing a correlation. A correlation is only when both of those variables are measured in a continuous way. Our groups already exist in the real world, so the researcher is not creating them. There's no manipulation. So unlike an experiment where maybe we would have kids come into the lab and we would manipulate their sleep to look to see does the manipulating sleep create a difference in impulsivity symptoms. So we're kind of flipping it on the end and asking a question about whether sleep impacts ADHD symptoms. In this kind of differential research, we're not manipulating anything. We're just measuring two things as they exist in the real world. No manipulation. That's why it's not an experiment. Another key feature is that the researchers aren't measuring any other possible third extraneous variables to make sure that our groups are equivalent in it. And in this way, we're not controlling for confounds. So this is the real way that quasi-experiments and non-experiments differ. So differential research with all those key features falls into the category of non-experiments. So the real challenge here is something called assignment bias. So here's your definition from the textbook. It's when the process used to assign participants to different groups results in groups with noticeably different characteristics. So all of those possible third variables, extraneous variables, means that our ADHDers and our non-ADHDers are different, not only in the question, the factor that we're interested in, which is their mental health or ADHD status, but they're also differing in these other things. So this precludes a clear cause and effect explanation and is a threat to internal validity. So internal validity itself can be measured in a continuous way, and a study can fall anywhere from low to high. This kind of design, differential research, all non-experiments, falls pretty low in the internal validity scale. So does this mean that this kind of research should never be done? Well, no, but we have to, as researchers, be cautious about the interpretation of our results and acknowledge that there could be other factors that could play a role. Wherever possible, we want to avoid doing a non-experiment and do a quasi-experiment where we're at least measuring those other variables and making sure groups are equivalent in terms of them. And it also means for you as people who are reading science, reading literature, I hope that you'll also be asking these questions about where does this study fall in terms of internal validity? Can I trust the design? Can I trust the results? Or could there be some other alternative explanation for the results? So again, we want to be looking at least at quasi-experiments or experiments that fall hot towards the higher end of internal validity. So at this point, I thought I would just do a quick little recap to make sure we're all on the same page, because I know these terms can be tricky. Internal validity, here's the definition, is the extent to which the research study produces a single unambiguous explanation for the relationship between two variables. So to make sure we're high in internal validity, we want to avoid possible confounding variables. External, so here we are. This is the schematic here. External validity is also important. It's the extent to which we can generalize the results of the study to people, settings, times, measures that weren't used in the studies. So we want a study that's also high in external validity, where we can ensure that the participants we recruit and the way we test them, well, that they're representative of the target population that we're interested in, doing things that are more real life, like real life scenarios. So on the external validity scale, experiments actually fall pretty low because you're taking people, you're putting them to a lab. They're maybe acting in ways that are not true to the way they would in real life situations. So on the external validity scale, quasi-experiments and non-experiments, because we're testing real life people and sometimes in real life situations, they can be higher on the external validity scale. So what you want is to try to maximize both your internal and external validity. So we're going to go back now and talk about these different designs and talk about the ways that they differ in terms of internal validity. In other words, which are better research designs that are high in both internal and external validity. And for this, I'm going to be using a bunch of examples that are maybe relevant to a lot of you. So I know a lot of you want to go into teaching or to work with children, maybe in a mental health capacity. A lot of questions that you're going to be maybe interested in, or a lot of studies that you're going to be coming across, fall into this category right here. So this is often used in educational research where we're interested in how children change with treatment or grow as a result of some programming or intervention. So let's talk now about how they differ and what you can look for when you're looking for studies to make sure that a treatment really does work. Now I'm going to use the example from the Right to Read inquiry. So this was a public inquiry that was launched fairly recently by the Ontario Human Rights Commission. If you haven't heard of it, check out this link. I highly suggest you check it out. So they launched an inquiry a few years ago about whether Ontario schools may be failing to meet the needs of children who are struggling learning to read. And what they found is yes, they are. And they highlighted a bunch of recommendations. So here are the sort of Coles Notes version of them to help address this problem. And in particular, I'd like to draw your attention to these two. So some of the main recommendations were that curriculum and instruction reflects scientific research about what works and how children learn to read. And for kids that are struggling readers, that they have access to interventions that work. So how do we know what interventions work? What kind of research can we trust if we're looking to implement some program to help our students? So in other words, how do you know if an educational program works? Does receiving a particular reading remediation improve reading skills in struggling readers? In other words, what is the relationship between remediation and reading outcomes? So I'm going to give you some examples of those different designs from that table from your textbook to highlight how we can ask this question. And all of them are going to be using the example from a intervention program that was developed by researchers at the Hospital for Sick Children. This program is called the Empower Reading Program. Maybe you've heard of it. It's been implemented in hundreds of schools across Canada, school boards across Canada, and across the world. The Hamilton Wentworth District School Board has been implementing it in their schools for over 15 years. The Niagara Catholic School Board has been implementing it for the last few years. So if we wanted to know if this program works, and we want to know what is the relationship between remediation and reading outcomes, well, we could do research designs in a number of different ways to get at this question. So we could compare reading outcomes in students who are struggling readers, and we could compare struggling readers that are at a school that offers the Empower Reading Program compared to students that are at a school that doesn't. So maybe take a local example, the Niagara Catholic School Board offers this program, but the District School Board of Niagara, the public school board, doesn't. So maybe we could take a group of grade 2 students who are at one school board, group of grade 2 students that are at a different school board, and look to see, are their reading outcomes different? So this would be an example of a post-test only non-equivalent control group design. I know the name is really, really hard to get your head, it's long, right? But it's really trying to explain what it is that you're doing. So we're using pre-existing groups. One group of participants gets the treatment condition, they're getting the Empower Reading. A second group is similar, but they're not getting that condition. There's no random assignment to groups. So we as researchers can't say, okay, you kid, you got to go to the school board, you got to go to the school board. We're just measuring these groups as they exist in the real world. And then we look to see, how do they differ in terms of their reading outcomes, which is the dependent variable in this case. So you can think of it schematically with these X's and O's that your textbook gives. So O's are when we're measuring when we're doing our testing, when we're measuring reading. So we're measuring reading in our two different groups, and one of the groups has gotten intervention and the other group hasn't. And we're looking to see, how do their reading outcomes differ, let's say in the spring after a year of grade 2 with intervention compared to without intervention. So what do you think of this design? Is it good? Is it bad? Is it a non-experiment that's kind of low in internal validity, or is it more a quasi-experiment that's more towards the higher end of internal validity? What do you think? Well, to answer that question, you got to ask yourself, what is a possible confound in this design, and are we controlling for it? So why don't you pause the video right now and think of what is a possible confound in this design? Well, hopefully you've paused the video and you're back. Well, you can ask yourself, what are other ways that the groups could differ that have nothing to do with the remediation? In other words, what are some possible assignment biases that could be happening? Well, there's a whole bunch of them, and they could fall into categories that are related to the school. So for example, it might just be that School class sizes are smaller in the Catholic school board than they are in the public school board. We know that that is important for children's reading. Maybe it's just the size of classes that if we find a difference between kids in the Niagara Catholic versus public school board, maybe it's just their class sizes are different. It's nothing to do with remediation. There could also be a number of factors that are related to the kids themselves, their family background, and importantly, we're not measuring their reading before intervention. How do we know that they were equally struggling readers? We have no idea. We haven't measured any of these things. So we have no way of knowing if it's the remediation or these factors. Another important variable is the placebo effect. So if we're taking one group of kids and giving them an intervention, any intervention, and we're comparing them to another group of kids that gets nothing, well, that group of kids that gets the intervention, they're going to feel pretty special. They're getting pulled out, for 1 hour a day, they're getting one-on-one time with a resource teacher. It could just be that, and that mere factor of they now know that somebody cares about them, regardless of what it is that person's teaching them. It could be that that is explaining the difference between groups. So we're not measuring any of these possible things in this design. So we have no way of knowing if these could be playing a role. We have no way of knowing if it is the remediation that's actually helping kids or not. So this kind of design is considered a non-experiment. It's not that great. It's pretty low in internal validity. We have the conclusion that we could draw from the study is that maybe children's reading scores are higher in that group of kids that got Empower compared to the kids that didn't, but we have no way of knowing whether it's due to actually getting the intervention. We can't say from this design whether or not the intervention works and whether it causes scores to improve. So, all right, let's talk about another design. So, because we can answer this question in lots of different ways. We want to know what's the relationship between remediation and reading outcomes. Well, maybe we could take one group of kids that are getting their remediation just at the Niagara Catholic School Board, and we're going to measure their reading in the fall and in the spring. So we're going to look to see how much growth do they make in that 1 year that they got intervention. So this is an example of a pre-test, post-test design. So we're making observations over time twice in one group of kids. We don't have a control group. We just have one group and we're testing them twice. Once before intervention, once after intervention. What do you think of this design? Do you think this would allow us to say that remediation works? If we find that scores are higher in the spring, so in June, after kids have gotten the Empower program for 1 whole year, we find that they've made improvement. Can we really feel confident that it was the intervention that caused the improvement? What do you think? Is this a non-experiment or a quasi-experiment? Well, to answer this question, again, you have to think of what's a possible confound in this design? What's an alternative explanation for the result? In this case, we're not comparing groups of kids, so it's not about differences between kids, but it's about ways that the kids could differ over time that have nothing to do with the intervention, that are just about time. So these are called time-related threats to internal validity. We're going to be learning a lot more about them in a few weeks to come. But for now, why don't you just think about what could some of them be? What are some ways that kids could differ from the fall to the spring in grade 2 that could improve their reading skills that have nothing to do with the particular content of the intervention? What do you think? Why don't you pause the video here and see if you can say it out loud? Well, hopefully you've paused it and you're back. Well, time-related threats to internal validity can fall into different categories. One of them could be maturation. So kids might have improved during the grade 2 year in their reading scores anyway. That has nothing to do with their intervention. We don't have a control group. We're not measuring that change. So we don't know whether the improvement that's due to the intervention is greater than that maturation might have been. Kids could also just get better due to practice. We're testing them multiple times. Maybe they're just getting better at taking the test. And so maybe their scores are better the second time they take the test than it was the first time, and has nothing to do with what they've learned in the interim. And then again, the placebo effect. because again, we're not comparing to a control group. It could be that the kids are improving over time, again, just because they've been identified as being worthy of getting special help, and maybe that is enough to make them want to try harder to improve. So in this kind of design, we're not accounting for any of these things. We're not measuring them. We're not controlling for them. So this pre-test, post-test design is considered a non-experiment. And it falls pretty low again on this internal validity scale. So the conclusion that we can draw from this design is that children's reading scores may be higher after remediation than they were before intervention. So kids improved throughout the year, but we can't say that it's due to the remediation. This kind of design does not allow us to evaluate whether the program actually worked. So what can we do? What can we do to at least try to overcome some of these threats to internal validity? Well, we can do an experiment, and we'll be talking about that over the next few weeks. This really truly allows us to move towards high internal validity, because the researcher in this case is randomly assigning kids to either get intervention or not and measuring their change over time. And because the researcher is determining who's getting what, we can feel really confident that any difference between groups is really due to the remediation. But sometimes it's not possible to do that. We can't assign kids to go to different schools. So the best that we can do is a quasi experiment. It's also sometimes called a natural experiment. And this kind of design, we're still measuring real life situations, but we're controlling for possible confounds. And there's two ways we can do this: a pre-test, post-test non-equivalent control group design, where we're comparing two groups at two different points in time. This is probably the most common design that you're going to read about in educational research. And for any of you doing your research proposal where you want to measure some effect of some treatment or some intervention, I highly suggest you do this design. And then we're also going to be talking about another alternative called a time series design. All right, so let me get started on that. So again, we're asking the question, what's the relationship between remediation and reading outcomes? And in this case, we're comparing two groups of students, one who gets intervention, one who doesn't. And we're comparing both of the groups. We're testing them twice, before and after that time period of intervention. So locally, it might look something like this, where we're getting a group of kids from the Niagara Catholic School Board that get intervention. They're identified as struggling readers, and we're measuring their reading skills in September and in June to look to see how much change do they make, how much growth do they show. And we're comparing that growth, that change, to a control group of kids, maybe from the District School Board of Niagara, who sadly do not receive remediation. And we're looking to see how much change did this group make. And our question now is, do the kids who get intervention, do they show greater change than the kids who don't receive intervention? So this is an example of a pre-test, post-test, non-equivalent control group design. So we're measuring kids twice, pre-test, post-test, and we've got two groups of kids. So one group is measured before and after treatment, and the other group is measured at the same two time periods, but they don't receive intervention. So this is what it might look like with these X's and O's. So O's again represent when the testing is happening, pre and post, and only one group is getting a treatment. So by measuring their reading skills before and after and looking at change in growth, we're controlling for one of those major threats of internal validity. We're at least looking to see what were their reading skills before intervention. So is this a non-experiment or quasi-experiment? Well, this would be an example of a quasi-experiment because we're at least controlling for one of those possible threats. And we can actually make quasi-experiments can fall towards medium or high internal validity depending on how many possible other extraneous variables we measure and control for. So maybe we also want to make sure that groups are equivalent in terms of how old they are, how many girls and boys are in each group, their IQ, and we might also want to consider giving the other group not only nothing, but maybe some other control conditions so that we can control for the placebo effect, or that idea that just being selected as being special makes you improve. So maybe we'd have two groups of kids, one group gets intervention, one group doesn't. We're selecting which kids we want to measure to test the effectiveness of programming learning so that the groups are equivalent in those other possible confounding variables. And one group's getting intervention, and maybe that other group is getting, I don't know, study skills training. They're still getting some sort of special programming. It's just not specifically related to reading remediation. So here's an example of a study that did just that. It was published by researchers from CHYS as well as Jan Freiders, who's from CHYS here at Brock University. So they recruited kids that got intervention versus didn't, who are at different schools, and before intervention, they matched their kids. So they made sure that the groups were equivalent in terms of how old they are, what their reading level was before intervention, what their vocabulary, intelligence, SES, things like that, and made sure they're equivalent. And then they measured their reading both before and after that time period. So this is the results that they found. So the gray bar here is the treatment group, the kids that got Empower Reading. Here is the gray group, the control group that didn't. And here on the y-axis, you can see what we're measuring. So we're measuring their adjusted post-test scores. So that means we're measuring their scores after intervention, controlling for what they had before intervention. So we're measuring the change that they made during that time period. And you can see that that treatment group made a larger change than our control group. So the conclusion from this study is that children that receive intervention show a greater improvement in reading than children who don't receive intervention. We still can't say that intervention caused the change, but we're getting a lot closer. And from this kind of design, we can feel confident that the intervention works. So after all of this, here are some questions for you to consider. And I think if you can answer these questions, it will really put you in a great place towards the final exam and really show that you understand this material. And we can chat about this for sure at our next class. So why do you think pre-test, post-test non-equivalent control group design has higher internal validity than those other designs we talked about? In other words, why is it important to have a pre-test, and why is it important to have a control group? What are we doing for assignment bias, and what are we doing for those time-related threats to internal validity? So again, let's talk about that at our next class. So finally, there's one last design that falls into the quasi-experimental category. It's called a time series design. So again, we can ask this question: what's the relationship between remediation and reading outcomes? And we can do this by comparing reading skills in grade 2 kids, not only before and after intervention, but we can measure them at multiple time points before intervention and multiple time points after intervention to look to see, does the rate of change, does the rate of learning after intervention, is it greater than it was before intervention? So is the improvement during that year they got remediation greater than any improvement they made before intervention? And does that improvement continue even in the years that follow? So this is called time series design. So rather than just measuring pre and post, we're doing a series of observations before and a series of observations after some sort of treatment or event. And the benefit of this is we can really see trends in the data, and it allows us then to measure them and control for possible time-related threats to internal validity, even without having a control group. So it looks something like this. We've got multiple time points before and then multiple time points after treatment. And our question now is the rate of change here different than the rate of change here? So I'll give you one example of a study that I've been working on that did just this. So at the time that I'm recording this video, it was just recently accepted for publication. And if you're interested, you can check out a preprint with this link here. So this study was done in collaboration with SickKids as well as the Hamilton Wentworth District School Board. And the Hamilton board, like I said, has been implementing the Empower program for many years. We had reading data from a large number of kids who got intervention in either grade 2 or grade 3. And this was offered by teachers, learning resource teachers in their schools, and they got the intervention for 1 hour a day, 5 days a week from September and June. So we used a time series design to track changes in children's yearly reading growth from kindergarten all the way to grade 5. And the question that we could ask from this is receiving the Empower Reading remediation associated with a long-term shift in children's reading trajectories? So here's an image from an infographic that we have on our website, right down there. You can check it out if you're interested. So I'll just walk you through what we found. So the teachers in the schools measured kids' reading using the developmental reading assessments, and they did this every year in the fall and in the spring of every grade. And so we had reading scores from kindergarten to grade 5. So here we can see their DIA scores, and here we have the different time points. This sort of blue box is the recommended benchmark. So this is the scores that ideally kids would show at each grade. The red line are the kids that were identified as struggling readers and who got intervention in grade 2. And the gray line are those struggling readers who got intervention in grade 3. So what you can see here is this, well, first of all, over here, this is their rate of change, the amount of learning that they made every year before they got intervention. So you can see it's pretty flat and they're not meeting those benchmarks. Here is now the rate of change that the grade 2ers showed in those kids that got intervention in grade 2. So you can see there's a big jump in their scores. And then this is the rate of change they made in the years after. So you can see most of them are now reading at grade level. And here are the kids in grade 3. So you can see there's this lag. They didn't get intervention until grade 3. And then boom, grade 3, big improvement in scores that continued even after. So the conclusion that we got from this study is that intervention works, even when it's implemented in schools. And we can see long-term shifts in children's reading trajectories that are linked, that are related, that are associated to receiving the Empower Reading intervention. And we can also see a faster rate of learning during their Empower year compared to the years before and after. So I know this was a lot, but hopefully now this table is less daunting. You've got an idea of what these different research designs are. Hopefully you can classify which ones are non-experiments, which ones are quasi-experiments, and explain why. In the next video, we'll be talking, it's brief, shorter than this one, I promise. You'll be learning more about developmental designs. So these are questions when we want to know, how do kids differ or change with age? So to summarize, non-experiments and quasi-experiments are often the research design used in applied settings when we want to compare pre-existing groups, when we want to look at the impact of treatment over time, or we want to look to see how age and development changes us. These are not considered true experiments because we're not creating equal groups. We're not using random assignment. So we can't be sure that we're measuring what we think we are. Quasi-experiments are always preferred over non-experiments, so please, for your research proposal, propose a quasi, not a non-experiment. And they're better because they're moving us further along this continuum towards high internal validity. We're controlling for possible threats, and we're controlling for them. We talked about 3 non-equivalent group designs. We talked about assignment bias, why it's a problem towards internal validity, and in why adding a pretest can help account for this. We also talked about 2 within subjects designs. We talked about time-related threats to internal validity, and we talked again about how time series designs and pretest, post-test non-equivalent control group designs can allow us to control for these, so why these are the quasi-experimental designs of choice. Stay tuned. In the next few weeks, we're going to be talking about true experiments and why it is they fall high on the internal validity scale. Thanks so much for listening, and we'll see you in the next video.